Okay, hello there, students. My name is Mr. Kennedy. I am a lecturer at ICS in the School of Information Communication Technology. Today, we are going to look at computer communications and storage devices. So, we look at computer communication devices and as well as storage devices for the computers. So, without further ado, let's get started. So we begin with the communication devices. And before we go to communication devices, maybe a bit to just talk about what is communication. Now, if you recall in our previous class, we mentioned something about communication. And we said communication is the process through which a message or an information is delivered from one point to the second point in a format that it could be understood in the intended way. So communication enables that way of the process of moving message from one point to the other, and the message must be understood in the way that it was intended. So that is communication. Now, so to aid that, we do have what we call communication devices to enable us to do the communication process for us to be able to move the message from one point to the other. So a communication device is a hardware device capable of transmitting an analog or a digital signal over the telephone, other communication wire or wirelessly. So we're talking of the signals. They could either be analog, they could either be digital, and then it's done over a telephone or other communication networks like the wired and wirelessly. So talking of things like television, in the ancient days, we even in Kenya not long ago, we used to have a case scenario whereby the communication media was analog based, and therefore the information was being transmitted from point A to point B based on the analog signals. Now we later migrated to digital. We migrated to digital format whereby now data is transmitted in digital signals. So it could be done wirelessly, like over the radio. It's done wirelessly. The TV is done wirelessly. You do not need to connect a cable one on one from one point to the other, but you can get those signals wirelessly. So there is always a computer somewhere to enable that, and therefore those kind of computers and the related peripherals, we refer to them as communication devices. Now, the best example of a communication device is a computer modem. Now, a modem. Talking of a modem, what might be a modem? Now, the word modem is derived from two terminologies. There are two terminologies that are related to the communication that gives rise to the modem, or from the point where that device we call the modem stands determines the name of that device. So the two terminologies, we have what we call modulation and demodulation. So modulation, demodulation, or modulator, demodulator. Now the device we call it modulator, demodulator. So it does modulation and demodulation. So from that we get the word modem, modulator, modem, more than dem. So modem, one is modem, modulator, the other is demodulator to form the modem. So what is modulation? Modulation is simply the process of transferring the signal from transferring the signal from analog to digital for transmission. From digital to analog for transmission, because the signals are transmitted in analog way in the air. So it could be in the analog way, and then later it will now be demodulated. Now picture this: we have 2 points, point A, point B. So point A is mpenzi mtangazaji, point B is mpenzi msikilizaji or mpenzi mtazamaji. Therefore mpenzi mtangazaji airs those kind of data or puts them in the air, and for him to be able to put it in the air, he must use what you call a computer or a device, and therefore the data comes from the computer in the form of a digital. The data that's on a computer is usually in form of a digital format. Now the data, so the data to be, in order for it to be aired, it must be converted from digital to analog. So that process whereby mpenzi mtangazaji tangazas the whatever data and then airs it, it's now converted. Now that kind of data moves to the point of mpenzi msikilizaji. Now for him to be able to get that kind of data in the format that is intended, he must have a device to convert it from their side. So to transform that analog signal back to digital so that they can understand it, we call that process demodulation. So they convert it back. In the air you could not hear anything, but once it gets on TV, you can now get to hear what the signal means. So modulator demodulation. So we get that device we call computer modem, which is mostly used in communication. Now the modem is capable of sending and receiving a signal to allow computers to talk to each other over the telephone. So it's capable of sending and receiving a signal. So it can send, whereby it does the modulation, then it can receive at the other end where it does the demodulation. So a modem looks like what you see on the screen. Now most of us usually just knows several modems. We know the modem that looks like a flash disk, a small device. That one is the one that's commonly known. The line is put in it. That one is usually to just serve a few people around or a single user, maybe you using it on your computer. But we do have a modem that serves a lot of people, and it could look something like what we're having here on the screen. The other examples of communication devices includes a network interface card, the NIC, Wi-Fi devices, things to do like the router and so on, and an access point. So we may need an access point, and those. So all those, they help in communication. So below is a picture of some of the different types of Wi-Fi devices. Now we've seen the modem, and we could see the network interface card. This one here, we call it the network interface card, and it's there to enable the computer be connected to the internet. So this one you can buy it separately, then you can insert it on a computer. Storage devices. So we finished the communication devices. We look at the storage devices. So a storage device is any hardware capable of holding information either temporarily or permanently. So it could be temporary or permanent. Highlight that. There are two types of storage devices used with computers. A primary storage device such as the RAM, and a secondary storage device such as the hard drive. Secondary storage can be removable, internal or external. So you have the two major types of storage devices, the primary and the secondary. So we start with the primary storage devices. The primary storage devices. Just like in business or in the normal living, we do have the primary ones, the secondary ones, then the tertiary ones, whereby the primary ones usually, when we are talking of the human beings or people, the primary ones, they are the needs that are very basic. A human being cannot do without them. The second one comes in to just supplement the primary ones. They might not be as basic as such, but they are there to facilitate life. So similarly, in a computer, we do have the primary memory and the secondary memory. And therefore, just like maybe you've guessed, primary is so basic to a computer, such that a computer cannot function without it. So the primary memory is the random access memory of a computer. It's temporary storage space for data when the computer is power on state. It is much slower than the registers in the CPU, but there is a lot more of it, more data storage capacity. Primary memory holds both data and programs, so note that it holds the data and the programs, and that's a basic thing, because our computer is only also about acting on data, taking in data, giving out data, and having programs to work on that set of data. So if this kind of memory is holding those two things, then it must be very basic. Once they are loaded for execution, so it holds that. Then we do have what we call the ROM or the ROM. We also call it the read-only memory. It also could be considered as the primary memory, but there's usually a lot less ROM than there is RAM. The difference between RAM and ROM is that data cannot be written on ROM. And that's why we are saying it is read only. So data cannot be written, data cannot be put on that. We can only extract data from it. Usually this one is pre-programmed or pre-installed and pre-programmed with the computer. So as it comes with it. But it's there to hold the important data, the important programs, but they are already inside. So you cannot write it to it, but you can only get it from that kind of the memory. So a primary memory is like a table of addresses and contents. Also, 4 or 8 bytes depending on the CPU type is grouped together to form words. So if you remember, we looked at data representation. So you could either group it in either 4 or 8 bytes depending on the CPU type to form a single word. So we do have what's called the 16-bit, then the 32-bit. We have 8, 16, 32 and 64 bits. So depending on what computer or type of CPU you are using to group to form words. So those addresses of the primary memory. Classification of the primary memory. Classification of the primary memory. The acronym RAM stems from the fact that the data stored in random access memory can be accessed, as the name suggests, in any random order. So from the name, it is random access memory, so that suggests that data can be accessed in a random order. Or we can also say, put another way, any random bit of data can be accessed just as quickly as any other bit. So there is no priority that this one can be accessed easily and that one no. They all can be accessed quickly and easily, all the same. So we call it random access memory. The most important things to understand about RAM are that RAM memory is very fast. Now, the reason is that for us to function very easily, because this, mind you, this kind of memory is holding the data, it's also holding the program, and these are the determining factors of the functioning of a computer. So for us as the users of the computers to get the results as quickly as possible, the memory also must be fast, and therefore RAM being the primary memory, it must whatsoever be fast. So the most important things to understand about RAM are that RAM memory is very fast. It can be written to as well as read. So RAM, you can write to it and then you can read from it. Now in memories, when we talk about writing and reading, just like a human being, you write on a book, then you read from a book. So when you write on a book, it means you're putting some wordings on that book. Then when you read, it means you're now getting the content from that book. So similarly, a computer RAM, you write. When we're talking of memories and we are talking of writing, we are meaning you put data in that storage device or you store. Now in a simple language, an example, it could be copying. You copy it to a flash disk. That one we will say you are writing. So so we are saying the RAM is very fast. It can be written to as well as read. It is volatile. Now when we talk about volatile, we mean that as soon as the power goes off, all the data that was stored on the RAM is lost. So RAM holds data as long as power is on and as long as you're using that program. So it holds that data. Once it goes off, you lose everything that was stored on the RAM. So that means it is volatile. Then finally, it's very expensive compared to all types of secondary memory in terms of cost per gigabyte. So a RAM like today, if you only buy a 4 GB RAM, you could end up spending a 4 GB RAM goes for around 3,500, around there, 1,000, 2,000 to 3,000, around there. Now that's only 4 GB RAM. Now let's assume it's 3,000 shillings. 3,000 shillings, it's enough to buy you a 250 GB hard disk. 250 GB hard disk you could manage to buy with that. And actually, for only 4,500 shillings, you could be able to get 500 GB. So you compare the two per gigabyte or per GB, you get RAM to be very, very expensive. So it is because of the relative high cost of RAM compared to secondary memory types that most computer systems use both primary and secondary memory. So yeah, if we were only to use the RAM, then we would end up spending a lot of money to be able to store the data. So we opt to use both the hard disk and the RAM. The hard disk representing the secondary memory and the RAM representing the primary memory. Now, just before we move on to highlight, now if at all someone asks you, can you highlight 3 features of the RAM? They are all in this kind of a statement or this paragraph right here. Access is random and fast, as you can note the first feature. The second feature, we said it's volatile. Volatile meaning it can lose data as soon as power goes off. Then it is expensive per gigabyte. It is expensive per gigabyte. So those are the features of the RAM, if at all you are asked. Data that is required for imminent processing is moved to RAM, where it can be accessed and modified very quickly so that the CPU is not kept waiting. So mind you, you've said the RAM stores those data that are to be used by the CPU and also the programs. So these are being stored on the RAM. They're being stored on the RAM so that the CPU can access them quickly. Mind you, the RAM speed of accessing the RAM, either writing or retrieving, it's very fast. So those imminent processes or the data that's required for imminent processing, the process that is just about to take place or to happen very soon, it's stored on the RAM. So when the data is no longer required, it is shunted out to slower but cheaper secondary memory. So we say that since it's required, we store it to the RAM. But once it's no longer needed, it's shunted or fitted with the electric shunt to the secondary memory or to cause it to move. Now the term shunt simply means we move it out. So it's shunted out to slower but cheaper secondary memory. And the RAM space that has been freed up is filled with the next chunk of data that's about to be used. So you realize that you might end up running different programs. So as long as I close that program, the data relating to that program is closed. Then I open another data, or I open another program with another set of data. So the RAM looks something like that usually, um like what you're seeing right there. Now each computer has its own different kind of the RAM. So this one, mm, usually we call this one DDR3. You have the DDR2, DDR3, DDR2. So each computer takes in a different kind of RAM depending on the slot provided. So anyway, so then the RAM will have different memories and so on and so forth. So this one on the screen, we call it the computer RAM. If you do have a PC, you can go on, open it and look for something like that. It usually you can just take it out and take it in. Simple. It has no risks so long as the computer is off and the power is out of the computer. So there's no risk. Once the power is not connected, you can remove it, start it, then return it later. Types of RAM. We need to look at the types of RAM. So the first one, we call it the DRAM, which stands for dynamic RAM, or the dynamic random access memory. The DRAM, dynamic random access memory, and it is the most common type of RAM used in computers. The oldest type is known as single data rate SDR DRAM. So that's the oldest, but the newer computers use faster dual data rate DDR. Like I mentioned, we have the DDR2, DDR3, blah blah blah. So the newer computers use faster dual data rate um, dynamic RAM. So DDR comes in several versions, including DDR2, DDR3, and DDR4, which offer better performance and are more energy efficient than DDR. So the DDR2, 3, and 4, they are more efficient than the just DDR. So get that clearly. Dual data rate, the DDR, the dual data rate, because these are the terms you're likely to hear mostly around computers. So it is more efficient in terms of energy and so on. So however, different versions are incompatible, so it's not possible to mix DDR2 with the DDR3 dynamic random access memory in a computer system. DRAM consists of transistor and capacitor in each cell. So the second category, or the second type of RAM, we have what's called the SRAM. SRAM, which is also the static RAM. Now the first one was dynamic. This one is static, and it is a particular type of RAM which is faster than the DRAM, but more expensive and bulkier, having 6 transistors in each cell. For those reasons, SRAM is generally used as a data cache. Cache, there are people who say it's cache, but it's used as a data cache within a CPU itself, or as a RAM in a very high-end server system. A small SRAM cache of the most imminently needed data can result in significant speed improvement in a system. So static, now static, as you know, the term static is usually like just something that is still, and then dynamic can change. That's it is existing in DDR, the dual data rate. So the key differences between the DRAM and SRAM is that SRAM is faster than DRAM. That one we've mentioned it. So you need to emphasize on that. The SRAM is more faster than the DRAM, perhaps 2 to 3 times faster, but more expensive and bulkier. So bulk means it's also in big size. SRAM is usually available in megabytes, while DRAM is purchased in. So SRAM is usually available, you can go and buy. DRAM uses more energy than SRAM because it constantly needs to be refreshed to maintain data integrity, while SRAM, though volatile, does not need constant refreshing when it's powered up. So yeah, DRAM needs that kind of refreshing, and therefore in terms of energy it uses more energy compared to SRAM. And then we said that SRAM is more faster. So those key differences, have them at your fingertips. The DRAM, the SRAM being faster than the DRAM. Now, yeah, I'm just gonna be using those initials, but you know that DRAM currently means the dynamic RAM, the SRAM means the static RAM. So that is about the RAM, the DRAM, and the SRAM. So number 2, memory that's under the secondary memory, or the example of another example of the secondary memory, we have what's called read-only memory. Now, before we go even further, the name itself tells us more about the memory. Read-only memory, so it only allows reading. That means you can only get the data from the memory, but you cannot put the data to the memory. So this kind of memory usually comes installed with the computer, or you can buy it with the CPU, but it is pre-programmed and pre-filled with the kind of programs and data that you need in order to run whatever you do have at hand. So this one cannot allow writing. So read-only memory is an integrated circuit which is pre-programmed with specific functional data at malfunctioning time. It is also called firmware. These ROMs are not limited to computers only. Most of the electronic gadgets utilize its flexible functionality. In this, we will try to understand what is ROM, how it works, its types, applications, advantages, and disadvantages. So we will try to look at that. However, my point of interest is how to understand the ROM. Though you can go check up how it works, its types, applications, advantages, and disadvantages. So ROM is the acronym for read-only memory. ROM is a type of primary memory. As the name suggests, content can be read only but cannot write on it. One cannot write on it. It is a non-volatile memory, and therefore when the computer goes off and on, the ROM is still there. So unlike the RAM, the ROM is not volatile. So it's a non-volatile memory, and so the data is retained even when the power is switched off. The data that is required to be stored inside the ROM is written during manufacturing phase. So we said the ROM is pre-programmed and fed in with the functional data that you require, or that will enable the computer to perform the tasks. So when we say pre-programmed, we mean it was fed in a form of a program. So at manufacturing, when it was on a company, it was fed in. Therefore, that is it. If someone messes up with it, then it won't function because you cannot write to it. It stores such programs that are essential for the booting process of the computer. it generally cannot be altered. However, technologies are available to program these types of ROM. So technologies are there to type or to program it. But now these are the latest. But now you as the user, you cannot be able to write to it as a form of uh, maybe storing data, but you can only use the data that is already there. So how read-only memory works? How does it work? A read-only memory operates like an array. Now, an array, if you've done programming, you understand what an array is. An array is a collection of items, be it numbers, letters, or names. So ROM chips contain a grid of rows and columns to turn on or off. It uses a diode to connect the lines if the value is 1. If the value is 0, then these lines are not connected at all. Each element of the array corresponds to one storage element in the memory chip. The address input to the chip is employed to pick out specific memory location corresponding to the array index. The value read from the memory chip corresponds to the contents of the selected element of the array. So yeah, if we select array 4, the value that we read corresponds to the value that was present on that array. ROM consists of two basic components, the decoder and the OR gates or the OR gates. In ROM, the input to decoder will be in a binary form and output will be its decimal equivalent. So that decimal equivalent of that binary form will be the output. But when inside, it will be in a binary form. That's what we looked at in our previous classes or the previous class when we were talking about the number system, where we looked at the binary numbers, the decimal numbers, the hexadecimal numbers, and the octal numbers. So we tried also to convert that, and therefore you could understand easily what we're talking about. So we're saying that while it is inside the ROM, it is in the form of a binary form because a computer's language is in the binary format. And then the output will be in the equivalent of the decimal. Remember, human beings understand the decimal numbers, 1, 2, 3. So if today I'll tell you 1, 2, 3, a, that one you won't understand. Or if I tell you 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, you won't understand. That's a binary number. When I tell you 100, you understand. When I tell you 2000, you understand what that is. Those are decimal numbers. So the output will be in the form of a decimal equivalent of what was in the computer. So the input to decoder will be in binary form, and output will be in its decimal equivalent. All the OR gates present in the ROM will take decoder's output as their input. Types of ROM. ROM also has types. Remember the RAM, we've looked at the types, the DRAM and the SRAM. So Types of ROM. ROM is differentiated on basis of methods used to write data on ROM chips and the number of times they can be written. It can be classified into the following types. So before you go to the types, we look at the basis to which write data on the ROM chips. So it's differentiated on those bases. First basis of methods used to write data on ROM chips and the number of times they can be written. So we call it ROM. Remember, we've said there are technologies whereby we can be able to write data to the ROM. So they cannot be done by any other user unless it's a programmer using the available technologies. So that one will give rise to the types. So the first type, we call it mask read only memory. The mask read only memory, MROM. So the mask read only memory that refers to the MROM. It is a memory chip that is manufactured with its contents. So at the manufacturing place, it is manufactured with its contents. These are inexpensive and are very fast ROMs, which were hardwired devices that contain a pre-programmed set of data or instructions. These chips contain a software mask that is burned into the chip during design phase of semiconductor manufacturing process. The specification of ROM is taken by the manufacturer from its customer in tabular form and in a particular format. The manufacturer then makes the corresponding mask for the parts to produce the desired output. So if you wish to have your kind of ROM, you come tell us, then we make it, mask it, then we get the MROM. Applications of the MROM, they're used for network operating systems. So these are the operating systems that are found over the network. We use that. The server operating system, storing phones for laser printers, storing sound data in electronic musical instruments. So something like a keyboard. If you are going to play a keyboard, there are those sounds that are already there. You can just play it. Then there you go. You can choose a beat, then it just goes on and on and on. You do not need to play it using the keys. That sound, that beat, it plays on its own. So it initially came with the keyboard. There are other sounds which comes with the keyboard. Yeah. So we call those the instruments, and they've come in the ROM. Of course, the fonts for laser printers, we have the fonts that are stored inside that ROM of a printer. The server operating systems, then the network operating systems. So they use this kind of technology whereby the chips contain a software mask that is burnt on the chip during design phase of the semiconductor manufacturing process. The specification of the ROM is taken by the manufacturer from its customer. So the customer brings it, then they do as they wish. So these are the applications: network, the server, the font of a laser printer, the musical instruments. Advantages of mask read only memory. Advantages of mask read only memory. advantages of mask or the EMROM. The main advantage of the EMROM is its low production cost. The cost of the IC, those are the integrated circuits, depends on its size per bit. Mask ROM is more compact. It is significantly cheaper than any other kind of secondary memory when large quantities of same ROM are manufactured. So it's the cheapest among those types. Disadvantages of the EMROM: design errors are costly. An even error in the code is detected, the EMROM is useless and must be replaced in order to change the code. The life expectancy of EMROM is also short, hence requires frequent replacement. So we're saying that EMROM, it's done at manufacturing. So that means the mask is burned on that chip. So if an error is made, that means, once it's burned, it's burned. So if an error is made, that means we do away with that. Then we just come up with a different kind of a thing. So yeah. And then also the life expectancy of the EMROM is short. Therefore, someone needs to replace it frequently. Then we do have the second kind of ROM. We call it programmable read-only memory. The first one was the mask read-only memory. The second is programmable read-only memory. PROM. So PROM stands for programmable read-only memory. It's manufactured as a bank of memory. A blank memory. Now at manufacturing, it's not burnt like the EMROM. The data is not put in. So it's manufactured as that blank memory. And as its name suggests, programmable, it's programmed after manufacturing. The user buys a blank memory and enters the desired contents using a PROM program. So now assume we are a company, let's say for example IBM. IBM is a computer manufacturing company. Now assume that is the case. I don't want to market for anyone or mention anyone, but assume IBM is a computer manufacturing company, and therefore they need this ROM, but they need to program it themselves. They cannot manufacture the ROM, but they need to program it themselves. So they buy this programmable read-only memory, which they'll go and program. Now another company that produces the keyboards, for example Yamaha. Yamaha produces keyboards. So Yamaha produces keyboard. So what they do, they go buy the mask read-only memory and they give the specifications to the manufacturer, and the manufacturer, as he manufactures that, he puts the data already in the chip. So the two cases that when we buy from the manufacturer, the mask comes with the data already, but the programmable one comes blank. We go to program it ourselves. So the process of programming a PROM is called burning the PROM. We're burning the PROM. There are tiny fuses in the PROM chip which are burnt open during programming. The data can be programmed only once and cannot be altered. So it's called a one-time programming device. So as it came blank, once you program it and it's burnt, you cannot now again burn it. So still it's read only once it's programmed. Someone cannot program it once again. So it was bought blank, but now we can be able to burn it. Applications of a programmable read-only memory. Applications, the programmable read-only memory. So they are used in, number one, mobile phones for providing user interface selections. Yeah, so the mobile phones for providing user interface selections. Then video game consoles. Implantable medical devices. Implantable medical devices. Radio frequency identification tags. high definition multimedia interfaces. Those are the HDMI. So these ones, they come blank, but now they can be programmed by a programmer. Therefore, they are used in those areas. Advantages of programmable read-only memory. Advantages of the read-only memory. The programming can be done using many types of software and does not rely on hardwiring of the program to the chip. Now, since it's not possible to unblow the fuse, so the authenticity of the data remains intact, and it's possible to remove or alter the contents. The programming can be done using many types of software and does not rely on hard wiring of the program to the chip. That's the advantage number one. So you can do using many types of software. And then number two is, since it's not possible to unblow the fuse, so the authenticity of the data remains intact, and it's impossible to remove or alter the content. So once you've blown that fuse, you cannot again unblow it. So if the data was blown to it, yeah, we are sure that no one else can unblow it. Disadvantages of read-only memory, that is the programmable ones. The biggest disadvantage of PROM is that data once burned cannot be erased or changed when detected with errors. So it also has that error. Now, mind you, the MROM was at manufacturing, but now this one is at programmable stage. And once we program it, if we realize that there are errors, then you cannot change it. So unless we buy another device, then program it once again. Next kind of ROM, we call it erasable programmable read-only memory. Now, the programmable one was not erasable. You cannot erase anything. Once you burn it, you cannot undo it. But now we're adding on what we call the erasable, the EPROM. It is a non-volatile memory. It can retain data even if the power is cut off. The basic limitation being encountered in PROM is that once it's programmed, it cannot be changed or altered. So that one we're talking of the PROM, that once it has been programmed, it cannot be altered. Now, the limitation has been overcome by the EPROM. So what do we mean? We mean that the limitation whereby you could not alter something so long as you've programmed it already, now this time we can now reprogram it, or we can erase it and program it again. So EPROM comes in to take out the disadvantage of actually takes out the disadvantage of the MROM and the PROM. So you can now get to do that. So EPROM can be erased by exposing it to ultraviolet light, the UV, for a particular length of time using an EPROM eraser. After exposing, the chip returns to its initial state and can be reprogrammed. So it appears that this time we can unburn it by exposing it to the EPROM eraser. And after sometimes those chips return to the initial states and can be reprogrammed. This procedure can be carried out many times, but repeated erasing and rewriting can eventually render the chip useless. So just like in any case, use and disuse. I mean, wear and tear. The more you use something, it gets torn. Yeah. So the procedure can be carried out many times, but repeated erasing and rewriting can eventually render the chip useless. Once written, data can be retained for about 10 years. Applications of the erasable programmable read-only memory, the EPROM. Applications of the EPROM. The applications of the EPROM includes the following. Number one, as a program storage chip in microcontrollers. So it's used as a program storage chip in microcontrollers. So microcontrollers are those devices used to program other devices. Then for debugging, it also can be used for debugging. Debugging is that process of looking for an error in a program to take it out, or looking for a bug and taking it out. For program development, another one. Then as basic input output software chip in computers, input output or basic input output software chip in computers, it could be used. Then as a program storage chip in modem, video card, and many electronic gadgets. So the EPROM could be used that way. So that's why you find sometimes people they do reprogram those modems. Advantages of erasable programmable read-only memory. And I'm sure that by now you know one of the advantages, that we can use it and use it again and again, because it offers us that chance of reprogramming it, so we can use it again and again. So number one, it's non-volatile. Then it can be erased and reprogrammed, like I said. So then it's cost effective compared to PROM. Disadvantages of the erasable programmable read-only memory. The static power consumption is high, as the transistors used have high resistance. It's not possible for a particular byte to be erased. Instead, the entire content is erased. So you cannot just erase a given thing, but you have to erase the entire thing for you to get the desired content. Then the UV-based EPROM takes time to erase the content. Then also we said that with the time of erasing, then it could shorten the lifespan of that particular erasable. So this one was it is what you call the UV-based EPROM. Then next we call it electrically erasable programmable read-only memory, the EEPROM. The EEPROM. Yeah, so the names actually they are suggesting what you're talking about. Electrically, we are using electric erasable. You can erase. Programmable, you can program read-only memory. So it is similar to EPROM, and thus developed to overcome the drawbacks of EPROMs. So EPROM, we said it's erasable. It was EPROM came to do away with the shortbacks or the throwbacks of the drawbacks of the PROM. But now the EEPROM now comes in to deal with those shortcomings of the EPROM. Now the EEPROM kind of acts better, but it acts in similar way. So it's erased and programmed electrically. It uses electrical signals instead of the ultraviolet rays. Now mind you, the last disadvantage we said, the ultraviolet rays takes time to erase that data. So the erasing and programming of data takes 4 to 10 milliseconds. Any byte can be erased at a time instead of entire chip. So with this one, any byte can be erased. With the electronic one, the chip can be erased and reprogrammed for around 10,000 times, though the process is flexible but slow. So you realize that this time we can erase a given specific byte, but in the latter, or the EEPROM, we had no choice but to erase the entire data. So long as we spot one byte which has a problem, then we have to wipe out everything and reprogram it. But in this case, we can choose that single byte. Application of the EEPROM, applications of the EEPROM as BIOS in chips in computers, then as storage for reprogrammable calibration information test equipment, as storage for inbuilt self-learning functionality in remote operated transmitters. Advantages of the EEPROM: the method of erasing is electrical and instant, unlike the ultraviolet, which was taking time. Chip can be reprogrammed infinite number of times. We've talked of 10,000 times, which is a lot of times. Then byte-wise, data can be erased instead of the entire content on the board. Then to change the data, additional devices are not required. Disadvantage of the EEPROM: different voltages are required for erasing, reading, and writing the data. The data retention period of EEPROM is limited, i.e. 10 years approximately. EEPROM devices are expensive compared to others. Then we have what we call flash read-only memory. It is the universal flash programming non-volatile utility. It is used in computers as a storage medium. It can be electrically erased and reprogrammed. In this, memory blocks of data 512 can be deleted and rewritten in a particular time. The applications: the latest technology computers uses BIOS stored on a flash memory chip called a flash BIOS. Modems, pen drives, small cards use the flash ROM or the ROM. Advantages: high transferring speed. It saves data when turned off, preserve its state without power, less prone to damage, comparatively economical. Disadvantages: comparatively costly than hard disk, number of read writes are limited, very inexpensive, memory is retained even when the power is turned off, durable and last a long time. Archived data can be overwritten on read-only CDR, blah 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 blah. So we come to the secondary memory. So secondary memory is what the disk drives are. Places data can be stored and kept there even after the computer turned off. That is the secondary memory. Types of secondary memory: data storage has evolved in recent years, and storage devices can vary in cost, performance, size, and storage space quite a bit. Now, the first one, we have what called the magnetic storage devices. The first type of the secondary memory, magnetic storage devices. These are examples of the hard drives that are primary storage device in most personal computers. So, in short, there is a magnetic or the magnetism used in the storage of data. So, hard drives use magnets to record data on rotating metal plates. So it uses magnets to record data, and also to extract that data it uses magnetism. So it looks something like this. These are the normal hard disks that you usually see, and we have this thing here spinning. Every time you put a hard disk or a computer on, this part here spins. Then we have these headers being able to read the data from that disk. Benefits of a magnetic storage devices: solid state drives are only they're faster than hard drives. However, the cost to store data is pennies per gigabyte. So in short, the magnetic are very cheap. Like I mentioned, with 4K you can find a 500 GB. Advantages of magnetic: they are inexpensive, very fast access to data, direct access on any part of the drive, very large amounts of storage. Disadvantages: data can be altered by magnetic fields, dust, mechanical problems. Then it can gradually lose their charge over time, and the data can be lost. Hard disk eventually fail, which stops the computer from working. So if it fails, then the computer fails to work because you stored, uh, if it's the operating system on that kind of memory. The surface of the disk, that is the disk I've just shown you, could lose data within sectors with regular crashes. So if it crashes, then the data can be lost. Cannot transfer the disk to another computer easily. Yeah. Then how we come to the second of the secondary one, we have what's called the optical storage device. And the first picture I'm showing you, we call it a DVD. Now people confuse the DVD with the DVD player. This is what we call a DVD, and that thing you enter call it that home theater or anything. The one you enter this kind of a disc, that one is what we call a DVD player. But this one is called a DVD. That CD, it's called a DVD. So it's kind of large. So optical drives include CDs, DVDs, and BDs. BDs, Blu-ray discs. Now these ones look more or less the same. The only different is that the size. CDs are around 700 MBs. DVDs are around 4.7 GBs. Blu-ray discs are around 120 GB. So you can find a Blu-ray disc holding a lot of data. If it's movies, it holds a sort of a collection of movies on just a single disc. So they look round, look similar, but they have that. And they all use lens to read and write information. You have the CDR, DVD-R, and the BD-R can be written to once, and from there they are read only. So you buy a CD, a DVD, a BD that are only labeled R. That means you can only copy to it, whereby we usually call burning. You can burn to it once, and once you burn to it, you cannot delete that kind of data unless you just throw it away and then buy another one. On the other hand, they have what called CD-RW, DVD-RW, and then BD-RW, which are read and write, so they can be written on many times. That means you can erase the data on it, then be able to copy. And actually, the difference is the price. You'll find this RW being more expensive than the earlier ones. Benefits of the optical storage devices: CDs, DVDs, and Blu-ray discs are great to record music, movies, games, and software applications. It seems with optical storage, an advantage can also be disadvantage depending on how they are being used. But those are the functions, mostly those music and movies. Advantages of optical storage devices: optical discs are portable and can be read on many different times. Disadvantages: require special drives to read and write. We need those DVD drives, CD drives, and so on. Compared to other storage devices, they have little storage and then can be expensive per GB or per TB. There are compatibility issues with different drives. Lastly, we look at what we call solid state storage devices, the SSD, the solid state storage device, SSD. Now, before we even move on, these are the examples, the memory cards that we do have, and the flash disks. So solid state drives use flash memory and could possibly make conventional hard drives obsolete. That means there's no movement. Like in the hard disk, there's movement. It has to rotate, and even the CDs and DVD, they'll have to rotate inside that drive. But with the flash disk, it's just obsolete. They are it is absolute. Now don't confuse obsolete and absolute. They're still, there's no movement. So these are compatible with SATA or SAS and use standard form factors of 3 blah 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 inch. Benefits of solid state storage devices is that they are durable, they are reliable, they have long service life, and can rewrite and erase data very often. Advantages of solid state devices. Startup is faster due to non-spin and are faster than magnetic drives, so they don't spin, so the startup is very easy. When seats on the hard disk are limited, they have faster launch times. Then they last longer and some are waterproof. All data stored can be scanned quickly for security purposes. Disadvantages: solid state devices are very expensive. You have to spend a lot of money. Vulnerable to abrupt power loss, magnetic fields, and electric and static charges. So you expose it to those conditions, they're vulnerable. Then limited write cycles wear out after around 100,000 to 300,000 times. High endurance, then larger erase blocks makes random write speed slow. And that marks the end of our class, or the finito. So you could talk to me if you have any questions. My name once again is Mr. Kennedy. Bye bye for now. Keeping safe. Take care. Don't misuse yourself. Respect yourself and respect God. Bye bye.